Chapter 10.4, use inscribed angles and polygons. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc of the angle. Alright, so this right here is the inscribed angle. Notice the vertex is on the circle itself, and the arc that it intercepts is this arc right here in red. So that is the intercepted arc. The angle sides contain chords of the circle. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So this right here is the inscribed angle. Okay, that's ADB. And this right here, going from point A along the arc to point B, that is the intercepted arc. So the inscribed angle is 1/2 the intercepted arc. So if we let the intercepted arc be x degrees, that means the angle is going to be 1/2 of x. So the angle right here is just 1/2 x degrees. Example 1, find the indicated measure in circle P. So we know that P is the center. Part A, the measure of angle T. So here we have the angle's vertex at point T. So this is angle T. Alright, and angle T extends like this. And we can see the arc that's intercepted goes from point R to point S. Alright, so we said before the inscribed angle, which is going to be the measure of angle T, is going to equal 1/2 of the arc, the intercepted arc. So that's the measure of RS. Now, you can plug in numbers if you like to. Sometimes it's better to multiply both sides by 2 to get rid of the 1/2. But I can see we have an even number, so I'm not too worried about it right now. And this is just 1/2. The measure of RS is 48. And half of 48 is just 24 degrees. So this right here is 24 degrees, half of the arc. Now let's find the measure of arc QR. Alright, so here's point Q, here's point R. The arc runs along QR. Okay, we do not have an inscribed angle for QR. However, we have this angle right here. That's 50 degrees. Alright, so if we do arc QT, that's just going to be 2 times 50. So the measure of arc QT is going to be 2 times the measure of angle R. And that's just going to be 2 times 50, which equals 100. Now, we'll fill in the 100. But that's not what they asked for. They asked us for QR. We said before that this circle is named P, so we know that P is the center of the circle. That means this line right here is a diameter, and it cuts the circle in half. So the arc that runs all the way from point T past Q and to point R we know that's 180 degrees. All right, that's just half a circle, or half of 360. So if the whole thing is 180 and this piece right here is 100, then this right here is just going to be 180 minus 100. So of course that's just 80 degrees. So that's arc QR. The measure of arc QR is just 80 degrees. Example 2, find the measure of arc RS and the measure of angle STR. Alright, so arc RS, it goes from point R to point S along the arc, like so. And we see the angle right here that intercepts the arc. That is just going to be angle U, because the vertex is at point U. Alright, so we said the angle is half of the arc. So the measure of angle U is just going to be half of the measure of the arc, RS. Now, since we don't have arc RS, we're not going to multiply it by 1/2. I want to get rid of the 1/2, and the way to do that is just multiply both sides by 2. So I'm going to multiply this whole thing on both sides by 2. Alright, 2 times 1/2 cancels, because 2 times 1/2 is just 1, and we're left with the measure of arc RS. Alright, we see angle U right here is 31 degrees, so we have 2 times the measure of angle U, which is 31, and that's going to equal the measure of arc RS. 2 times 31 is 62. Now they want to know the measure of angle STR. So STR is going to be this angle right here. Alright, so it's this angle, and it intercepts this arc right here. Alright, once again, we said the angle is half of the arc, so STR is going to be 1/2 times the measure of arc RS. And that's going to equal 1/2. We see that RS is 62. And of course, half of 62 is 31 degrees. So this angle here is 31. What do you notice about angle STR and angle RUS? Here is STR and here is RUS. Okay, we can see those angles are equal measure or congruent, and that's because they both intercept the same arc. See, they both extend and reach arc RS, so that's why the angle measures are the same. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So you see right here, we have angle D. Alright, and then the other angle is angle C. So I highlighted these two angles here, and notice they both intercept arc AB. Alright, so right here is arc AB. Since they both intercept the same arc, they're both congruent. So those two angles have the same measurement because they intercept the same arc. Alright, example 3, name two pairs of congruent angles in the figure. Alright, we can see this arc right here. That's KL. So we want to find the angles for that arc. Alright, if you look at this angle right here, this angle right here is KJL. So that's going to be angle KJL. And the other angle is going to be KML. That's this angle right here. Angle KML. So they both intercept the same arc. So we have KJL and KML. So here, KJL, this is not KML. Here we have KJL and KML. But we have to check the other part. Here we have KJL, we don't have KML. KJL, we don't have KML. So I think it's C. Let's check the other angle, pair of angles. Alright, on the other side we have this arc right here. And if you look at the angles, this angle right here, that is JKM. And then in blue, we have this angle right here. That is JLM. So let's see if we have it. Right here, JKM is congruent to JLM. We crossed the other answers out, so it's definitely answer C. Alright, please try guided practice 1 and 2. Find the measure of the red arc or angle. So right here is the red angle, and it intercepts this arc right here going from H to F. Alright, so we know that the angle, or the measure of angle G, is going to be 1/2 of arc HF. So that's going to be 1/2. We can see HF is 90. And of course, half of 90 is 45 degrees. Alright, number 2. Here's the angle right here. That's angle U. And we know that's going to be 1/2 of the arc that goes from T to V. Alright, we don't have TV, so I'm going to multiply both sides by 2 in order to get rid of the 1/2. And 2 times 1/2 just cancels. So 2 times the measure of angle U is going to be 2 times 38. And that's going to equal the measure of arc TV. And of course 2 times 38 is just going to be 76 degrees. Alright, please try number 3. So, we see that this angle in red intercepts this arc that goes from Z to M. Alright, so it's this arc right here. I'm actually not sure what letter this is supposed to be. Maybe it was supposed to be an N, I'm not sure, and it's just backwards. Anyhow, we can see this angle here in red. It intercepts that arc. Now, we don't have the measure of this arc here, but we don't need it because this angle right here also intercepts the same arc. Alright, it's the same one. So the measure of angle Y equals the measure of angle X. And we can clearly see from the diagram that equals 72 degrees. A polygon is an inscribed polygon if all of its vertices lie on the circle. The circle that contains the vertices is a circumscribed circle. So the triangle here, you can see all of the points are on the circle itself. Those are the vertices. Same with the quadrilateral. All the points or vertices are on the circle. So the polygon is inscribed and the circle around it is said to be circumscribed. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle and the angle opposite the diameter is a right angle. So you see right here, I guess we can assume this is the center. So that means this line right here that passes through the center is that line segment is a diameter. Okay, so that means going from A to C along the arc, that's going to be 180 degrees. Okay, because the diameter cuts the circle in half and makes a semicircle. Half of 360 is 180. And half of 180 is 90. So this angle right here is going to be 90 degrees. And the diameter is the hypotenuse. Okay, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. That means they add to 180. Alright, so we can see this quadrilateral has all of its points or vertices on the circle. So we want to look at opposite angles. So that's going to be F and D. Alright, so the measure of angle F plus the measure of angle D equals 180 degrees. Now if we look at the other opposite angles, we have G and E. So the measure of angle E plus the measure of angle G equals 180 degrees. Alright, so opposite angles are supplementary. Example 5, find the value of each variable. Alright, so we can see the quadrilateral is inscribed. All of the points or vertices are on the circle. So we just look at opposite angles. Alright, so we know that y plus 75 is going to equal 180. And as a result, this angle right here is just going to be 180 minus 75. And that's 105 degrees for angle Y. Now for the other opposite angles, we have X degrees and 80 degrees. So this angle right here, that's just going to be 180 minus 80. And of course that equals 100 degrees. So angle X is 100. or should I say x equals 100. It's really angle S, but x is the measurement. Alright, part B, let's look at angles across or opposite each other. We have 2B and 4B. Alright, both of them are in degrees. So 2B plus 4B equals 180. Combine like terms. 6B is 180. And dividing both sides by 6. B equals 30 degrees. And they just asked for the variable, but if they asked for the actual angle, you would just plug in 30 in place of B right there and right there. So the other pair of opposite angles are diagonal from each other. So this one here is 2A in degrees, and so is this one right here. So we have 2A plus 2A equals 180. Combining like terms, 2A plus 2A is 4A. And this is A times 4. The opposite is divided by 4. And 180 divided by 4 is 45 degrees. So that is for A. Okay, please try guided practice number 5. Alright, we said opposite angles add up to 180. We can see all the points or vertices are on the circle, so it's inscribed, and we know these two add to 180. So this one right here is just going to be 180 minus this angle right here. And that equals 112 degrees. For the other opposite angles, go across or diagonal. Alright, we're looking for angle X. We're looking to solve for X, and this right here, these two add to 180, so we just subtract 82 from 180. And that's going to equal 98 degrees. So this was for X, and this one here was for Y. Okay, please try number 6. Going across, we have this angle is 10x, and this angle is 8x. So 10x plus 8x equals 180. 10 plus 8 is 18, and we still have the x. The opposite of times 18 is divided by 18. And 180 divided by 18 is just 10. Okay, opposite angles. Once again, we're going from C diagonally across. Alright, this is C, and this one here is going to be 2C minus 6. So all we have to do is take this expression and this expression, set them equal to 180. So we have 2C minus 6, and we're going to add C, and that equals 180. Okay, combining like terms, 2C plus C, this is actually 1C. 2 plus 1 is 3. And we have negative 6. And that equals 180. Okay, the opposite of minus 6 is plus 6. Do that on both sides. Cancels here. Bring down 3c. And we have 186 right here. This is c times 3. The opposite is divided by 3. 3 into 18 goes 6 times. 3 into 6 goes 2 times. So c equals 62. Now they just said find the variable. If you wanted to double check, this c is 62, and if you plugged in 62 right here, you would get 2 times 62, which is 64, minus 6. That's going to be, I'm sorry, 2 times 62 is 124, minus 6. That's going to be 118. 118 plus 62 equals 180. So it checks out.